Z value at 95% level of significance, that is 5% level, okay, confidence level. So 95% confidence level and 5% level of significance. So we can remember this, no need to see the table again and again. That is 1.96. Here it is 3.125, that is greater than 1.96. So we have to take the decision accordingly. Okay, 5% level. Okay, so what decision we'll take? Because it is greater, we have to reject the null hypothesis. So the observed value of Z is 3.125, which comes in the rejection region. Okay, since R modulus of Z is greater than 1.96. So calculated value is greater than the table value, and thus H naught is rejected in favor of H1. That is rejected. H naught and H1 are complement of each other. No, if one is false, the other one should be true. Therefore, H naught it is in the favor of H1. So accordingly, we have to conclude, right? Accordingly, we conclude. Okay, we have to take the alternative hypothesis for conclusion. We conclude that the given figures do not confirm the hypothesis of 6 ratio being, so it is greater than or lesser than. So it is not 50% boys and 50% girls. It may be boys ratio, number of boys may be more than girl, or number of boy may be less than girl. So because we talked about the two-tailed test, right? In the two-tailed test, it may be greater than or lesser than. Now we'll learn about the important concept of p-value. Okay, all this time we have talked about the level of significance, right? And now we are going to learn about the new thing, that is the p-value. Nowadays, if you use the computer to calculate the test statistic, their p-value, you can see the p-value. So using the p-value, we can decide what decision we are going to take. So this is very important decision using the p-value, right? So what is p-value? We'll see. Nowadays, p-value is used more than our 0.05 level of significance and 0.01 level of significance. But our table, if you use any statistics software, or if you use the online calculator, it gives you the t-value. P-value. What is p-value? That is concept of p-value. That is, most of statistical software provides p-value rather than the critical value. So nowadays the p-value is always used rather than, now we are not using critical value nowadays. So p-value provides more information compared to critical value as far as rejection or do not rejection of H naught. We are telling the reject or do not reject, but p-value gives more information about that. So moving in direction, we note that in scientific applications, if you see the scientific application, one is not only interested simply in rejecting or not rejecting, but here, if you want to interested to assess how strong the data has the evidence. Now we are going to reject or do not reject is there, of course, obviously it is there, but how strong our decision, how strong our decision is. So that how strong our decision is given by the p-value, right? And whatever we have learned just now is whether to reject or do not reject the null hypothesis. P-value gives more information rather than the rejection or not rejection. That is how strong evidence, we have collected the evidence, how strong the evidence is. That is given by the p-value, right? For example, as we have seen in the above example, based on general procedure of testing hypothesis, where we tested the null hypothesis, H naught, that is theta, is a parameter that is lesser than or equal to 50 grams, and against the H1, that is theta, greater than 50 grams. The test to test the null hypothesis, we calculated the value of T, right? T statistics we calculated, that is 2.78. The critical value, that is Z alpha, at 0.01 level of significance. Z alpha, that is the table value, is 2.33. Since the calculated value of test statistics, what we got, test statistic, that is 2.78, is greater than the tabulated value. So we got some value which is greater than, that is 2.33. Therefore what we did, the decision taken was, we rejected the null hypothesis at 1% level of significance. That is, I am sure that 99% whatever I claim is correct. That is what we mean by the 90 means 99% means, if you repeat this experiment for 100 times, 99% it will be correct, and 1% I don't know, it is left for the choice. So 99% you are sure, pretty sure that whatever you claim is the correct. So that is what 99% talks about. That is the 1% level of significance, 99% level of confidence level. So confidence is 99%, level of significance is 1%. So this is what we concluded using the table value. Now, if we reject the null hypothesis at 1%, surely we have to reject it higher level. If it is 0.05, 1%, 99% I am sure. That means you are sure 95% also. Right? If I say that 99% I am sure, that means you are sure for 95%, 75%, 35%, all this percent you are sure. That is a higher level is 99%. That is 1% level of significance. That is alpha equal to 0.05, Z alpha is 1.645. Z alpha, that is, if you see 0.10, 90%, it is still smaller, right? If you see the Z 90%, it is 1.28. However, the calculated test statistics is much higher than 1.645 and also 1.25. Therefore, the question arises, could the null hypothesis also be rejected at values alpha smaller than 0.01? Is it quite possible, right? At 0.01 only we have tested, but is it possible that if it is lesser than 0.01 also we have to reject it? So this question arises in our mind. The answer is yes. Is it quite possible? We'll see. So we compute the smallest level of significance. Now we are interested in how much smallest level of significance we can take the conclusion whether the null hypothesis is rejected. So the smallest level of significance alpha is known as the p-value. So here comes the p-value, the smallest level of significance alpha where we reject the null hypothesis, that is known as the p-value. So the p-value is the smallest level. What do you call that? The p-value. P-value is nothing but the smallest level of significance alpha at which null hypothesis can be rejected using the obtained value. That is the, we calculated using our observation, that is our sample, we calculated some value. So using that calculated value of the sample, that's a test statistic, to what percent level, that is the smallest level, we can reject the null hypothesis. That is the question here. So we define the p-value is the probability of obtaining a test statistic equal to or more extreme, that is in the direction supporting the H1. The H1 is true, to what percent H1 is true, what is the level, right? The p-value depends on the type of test. What are the type of test you are using? That depends upon the p-value. If the test is one-tailed test, p-value is defined as, so one-tailed test, the p-value differs, and the two-tailed test also p-value differs. So in the one-tailed test there are two cases, it may be right-tailed test or it may be left-tailed test. Therefore p-value for the right-tailed test, that is p-value equal to p probability of test statistics, that is t, observed value of the statistics. So we have to consider the test statistics and the observed statistics. Using the observed statistics is something but we have calculated using the sample, and the test statistics is okay, that is p of test statistics is greater than, whatever we calculated is greater than or equal to observed value of the test statistics. In that case that is known as the p-value. Now we go to the left tail test. In the left tail test, p-value is nothing but test statistics is lesser than or equal to observed value of the test statistics. So here it is greater than or equal to because it is right tail test. It is less than or equal to because it is a left tail test. If the test, okay, is two-tailed, then the p-value is defined as p-value equal to two-tail, no, that is why 2 is multiplied. 2 times p, that is test statistic, is greater than or equal to observed value of the test statistics. Now, procedure for taking the decision about null hypothesis on the basis of p-value. Now you are having the p-value. Now you have to take the decision whether to accept or reject whether to reject or do not reject the null hypothesis. We have to take the decision. So decision is taken on the basis of the p-value, right? To take the decision about the null hypothesis on, okay, based on the p-value, p-value is compared with the level of significance alpha. If the p-value is equal or less than alpha, so whatever p-value you are getting, the p-value is lesser than or equal to alpha, then we reject the null hypothesis. Okay, if p-value is less than, that is we want a 0.01 level of significance. If the p-value is 0.001, then p-value is less than the alpha. Okay, therefore we reject the null hypothesis. And thus if p-value is greater than alpha, that is we want to take 0.01, but p-value is 0.015. So 0.015 is greater than 0.01. So greater than, therefore we do not reject the null hypothesis in this case. So if we test our hypothesis with the help of the computer package or software, SPSS, all the software if we use, or if we use the computer also, online computer also, you can calculate. So it gives the p-value. Using the p-value, we can take the decision, right? In this case, using the p-value, we can take the decision. I hope you understood. So the software out using the p-value, the hypothesis testing procedure. Okay, p-value is a part of our output of the, whenever you see software in the output, p-value will be given. So using the p-value, whether to reject or do not reject the null hypothesis, you can take the decision. Now we'll go to the question. Testing of hypothesis for population mean using z-test. Okay, we have seen already, once more we'll see, that is testing of hypothesis for population mean using the z-test. So how we are going to take the decision using the z-test? Population mean is taken, right? So look at this question. A light bulb company claims that 100-watt bulb, okay, light bulb, it sells, okay, what it is doing, a light bulb company, that the 100-watt light bulb itself has an average life of 1200 hours. So average life of the bulb they are selling, no, that is 100-watt bulb, its average life is 1200 hours, and it also standard deviation is also given 100 hours. So for testing the claim, 50 new bulbs, what is 50? Our size of the sample, because we are going to select 50 bulbs. Because we selected 50 bulbs from the whole population, our 50 will be the sample size, were selected randomly and allowed to burn out. So it will be kept on for 1200 hours, and we are going to check it. So it was found that 1180 hours. The bulb is on for 1180 hours, but this hour is greater than our, this hours is lesser than our claim, that is 1200. And is the company's claim true for 5% level of significance? We are going to say whether it is true or false, true or reject. So we are going to say whether it is true at the 5% level of significance. So we'll go to the sum. So we'll be solving the sum in the next class. This is our example 3. Okay, what and all given in the question, we will write it down. In the question it is given mu naught is 1200 hours. Okay, and then population standard deviation is 100 hours, and the sample size is 50, and x bar sample mean is 1180 hours. Okay, So these are the information given in the question. What is the sample mean? The population mean is 1200 and population